Hi everyone, welcome to chapter 4 where we get to learn about quadratics. So quadratics are functions that have an x squared in them. The basic function would look like this. Y equals ax squared plus some number x plus a constant. That's what it would be in standard form. In today's section we are going to look at something called vertex form. But before we do that, we're going to go back to what we did before, and we're going to look at what we're going to call the parent function, which means the absolute simplest quadratic we can possibly have, and then deal with it step by step. So the parent function of a quadratic is here. F of x is x squared, or y equals x squared, just absolute basics. And I built a table based on this equation. I picked some numbers, some inputs for x, just around 0, -2, -1, 0, 1, and 2. And then I squared them. And because it's a negative, -2 times -2 became +4, right? So here is what came out. These were my outputs, or my range, my y's. Now what I want to do is graph them. Here is my basic graph of my parent function, f of x equals x squared. There are some parts to this graph that I want you to understand. Notice it looks like what we call a parabola. So a parabola is that nice curved function. Some of them, when you think of your dish for your TV, on the side of people's houses, they're shaped, they have a parabolic shape to them. So in any case, this point right here at the bottom of this bowl of our parabola is called the vertex. Really important point is the vertex. Notice that if you take this, I can divide it exactly in half right through the middle. This line that goes through the middle of the parabola is called the axis of symmetry. These are important elements of a parabola. Axis of symmetry. And each side of my parabola is a reflection of the opposite side. Both halves are exactly alike, always, always. So if I folded it along this axis of symmetry, all these lines would be equal distance exactly apart from each other. That's a characteristic of parabolas. In this case, my vertex is 0, 0. Nothing special because this is the parent function. My axis of symmetry is this line that goes through the x-axis at 0, so it is the line, let me write these down. This is the line x equals 0. If you look at your vertex, your axis of symmetry will be whatever the x of your vertex is. X equals that x. It will be the same thing. You're going to be asked to identify vertices and vertices and axis of symmetry, so I want you to know how to do that. Let's look at what happens if we change this parent function by putting this multiplier out in front. So now instead of just f of x is x squared, I have f of x is 1/2 of x squared. So I started by building a table like I did before, and now I'm going to go through what I did. -2 squared would be 4, but half of 4, this would be a 2. And -1 squared would be 1, but half of that would be 1/2. This is still a 0, so this is also 1/2 and 2. Let's look at what that graph looks like. If you notice, this parabola is still, well, I drew it myself, but it's still a parabolic shape, but it is wider and flatter. So if this number is less than 1, it is going to stretch and make the parabola wider this way. If it is larger than 1, it will narrow the parabola and make it steeper and thinner, like that. That's what this kind of number, that's the effect that it would have. Let's change it another way. Now instead of a positive 1/2, I have a negative 1/3. What kind of effect will that have on this parabola? So now when I built my table, I changed a couple numbers. Since I'm doing 1/3, I changed this to 3s instead of 2s. Let's see what comes out. -3 squared is 9. 1/3 of 9 is 3, but it's -3. And this would be 1 squared, 1/3, negative 1/3, 0, negative 1/3, negative 3. Because 3 squared is 9, and negative 1/3 of 9 is negative 3. Let's plot those points, see how that looks. Okay, here it is. It's actually even a little bit wider than the 1/2, and it's flipped. This negative one made it flip upside down. So now, instead of having a bottom to our bowl, we have a top to our bowl. Those are important terms. This one, this parabola here, when this was positive, my parabola opened upward and it had a bottom to it, or a minimum. When it's negative, my parabola opens downward. These two things go on for eternity, for infinity. The whole parabola opens downward, and I have this top to my bowl, or a maximum. A minimum or a maximum. You are going to be asked what's the minimum value and what's the maximum value. So remember, the axis of symmetry was the x of our vertex. The minimum or the maximum is the y of our vertex, because it's how high or how low our parabola goes. Here's how you can remember what to do. If this is positive, that means our parabola opens up. It's up, it's happy. If it opens up, it has a bottom, so it has a minimum. The y of your vertex, in this case it's 0, but the y of your vertex would be that minimum. If this is negative, your parabola opens downward. Therefore, our bowl has a top to it, or a maximum, and that maximum height is the y of our vertex. Okay, we talked about transformations of functions earlier. Now we're going to start really applying them in quadratics. Here is g of x. Let's deal with g of x. It's x squared minus 5. Do you recall when we talked about transformations what that minus 5 would do? Hopefully you remember. If you don't, this is how you can always figure it out. You build a table. So let's build a table of this. Let's put in these numbers and see what comes out. So if this is negative 2, this becomes 4. 4 minus 5, this would be negative 1. If this is 1, 1 squared is 1. 1 minus 5 is negative 4. And 0 minus 5 is negative 5. And negative 4. And negative 1. 2 squared, positive 4. There we go. Let's plot those points. So negative 2, negative 1. And what do we notice? This just shifted this original parent function down 5. That's it. All right. So if you could recognize that this just went down 5, you could have just put your vertex here at 0, negative 5, and then drawn your parabola from there, and it would have been easy. Here is another function. We'll call this one h of x. And this one is x minus 4 squared. Do you remember what this means to do? Okay, if you don't, you can always build a table. I knew what x's to pick. It could be a challenge, but I knew what to pick. So I made my domain 2 through 6. But let's plug those in one at a time and see what we get. If x is 2, 2 minus 4 is negative 2, that squared would be 4. If x is 3, 3 minus 4 is negative 1, that squared is 1. If x is 4, well that's 0. 4 minus 4 is 0. 5 minus 4 is 1. 6 minus 4 is 2. 2 squared is 4. Okay, so now our points are, okay, 1, 2, 3, 4, 5, 6. We have 2, 4. And look how it shifted it to the right. Do you remember when I said this is counterintuitive? This is a negative 4, so we think, oh, that must shift it to the left. Shifts it opposite direction to the right 4. So it took my parent function of x squared and shifted it to the right 4 because it's in here with the x, that's left and right. Remember, I hope you remember how we went through all these different transformations. Now we're applying them one by one. These two, this was the x squared and then minus 5, and this was the x minus 4 squared. These are translations. Okay, now I want to walk you through what is called vertex form. This is a form of a quadratic equation that gives us a lot of wonderful information, especially tells us what the vertex is. So that's why we like this form so much. I wrote it in a formulaic type of fashion. You really, really need these in your notes. I'm going to talk about what each part means and how to interpret it. And so if you need to take notes, go ahead. So here, this is solved for y. And notice we have a perfect square in here. So this A determines if our parabola opens up or opens down. If A is positive, it opens up. And if it opens up, it has a minimum, right? If A is negative, it opens downward, and our parabola has a maximum. So this A is really important to tell us that. Also, if it's less than 1, our A is broadened, compressed this way. If it's greater than 1, it is stretched, becomes narrower and thinner and steeper. Okay, so that's what all the things that A does, pretty powerful. HK is our vertex. Notice this negative, so if you're graphing it, finding the vertex, the H will be this opposite sign. That's why there's a negative in here. But HK is your vertex. And then that means your axis of symmetry is X equals H. And your maximum or your minimum is your K. Okay, so that's what all of this means. Let's look at what that looks like with a real equation. You are going to be given quadratics in vertex form just like this one, and you are going to be asked to give all this information from this equation. You won't have to graph it or anything, just identify these characteristics. So let's walk through this one at a time. All right, here's our equation, and the first question is, what is the vertex? So remember, in this formula, our vertex is HK. By the way, you might want to write vertex HK in your notes. So HK here, our H is 4, our K is -4. Change the sign, don't change the sign. So here our vertex is 4, -4. So if we were graphing, we would go to 4, -4 and plot our vertex right there. Our axis of symmetry then, that line that goes right through the middle of the parabola and divides it in half, is X equals 4. X equals whatever our H is of our vertex, right? The HK. X equals 4, that straight line through +4 is our axis of symmetry. Does this have a maximum or a minimum? All right, this 3 is positive, which means our parabola opens upward, therefore it has a bottom or a minimum. So you would need to write it has a minimum. What is the minimum? What's the bottom point that this parabola will reach? It's the y of your vertex. It's -4. It has a minimum of -4. All right, there. And what's the domain and range? And that we haven't talked about. So the domain and range means what values, what inputs can we use in this particular function, and what outputs will we get in this particular function. So in this domain, there is no limit to what our x's can be. We can put anything into this function for x, any value, and it's totally legit. So the domain is all real numbers, and you can just write all real like that. That means our domain, all real numbers, we can put anything in. Now the range is what's going to come out. And here you have to think with parabolas. Remember, this is a parabola shaped like a bowl that opens up, and it has a minimum. So the range, you're not going to have any outputs at all that are below that minimum. Everything is going to be from the minimum upward because it opens up. Do you see how that works? So the range is that all the y's, all the outputs, y's are going to be greater than or equal to that minimum value of -4. And that limits your outputs. That limits your range. So that's what you want to be able to identify and list. Let's walk through one more of these together just so that you feel really solid about it. Here is the equation. If you want, why don't you pause the video, see if you can answer these 4 questions on your own, and then you can restart your video and I'll talk through it. If you're feeling insecure and you just want to watch me do it, that's fine. But I'm going to go ahead and talk through this second equation just like we did the last one. So here's our function, quadratic function. The first question we want to answer is, what is our vertex? So for our vertex, we're going to look at our HK, remembering to change this sign. Don't change that sign. So therefore, our vertex is -1, 4. So what's the axis of symmetry then? Where is that straight vertical line that goes through the middle of our parabola? It's x equals the x of our vertex, -1. Okay, now, does this parabola have a maximum or a minimum? So now we look at the A portion of our equation, and notice this is -2. That means this parabola opens downward. And if it opens downward, it has a maximum. So we're going to write maximum. What is that maximum? The highest that parabola will ever get is the y of our vertex. The maximum is 4. Do you see how this works? So what's the domain and range? Again, so the domain, there's no limit to what we put in. We can put in any value we want for x at all. So it will just, in fact, our graph, any graph, left to right, will go on and on and on for infinity. So our domain is all real numbers. However, our range is limited. What comes out is limited because of the squared. Remember we said our parabola opens downward, so it has a maximum. Therefore, all our outputs are going to be below or equal to that maximum. So our range is y is less than or equal to that maximum of 4 because it opens downward. Okay? How did you do with this? This is why we're going to stop here. This is enough for one day. I want you to feel really solid about this, and then we will finish this section next time.